Hello everyone, welcome back to my channel. Today's video is going to be the second part of my energy series where I'm going to be talking about a different kind of energy today called kinetic energy. Kinetic energy is symbolized by a capital E and a subscript little k. In physics, the kinetic energy of an object is defined as a form of energy that it possesses due to its motion. When an object is at rest, it possesses no kinetic energy. Once again, there is a formula for kinetic energy, that is Ek is equal to 1/2 mv squared. Kinetic energy is measured in joules, mass is measured in kilograms, and velocity is measured in meters per second. Now, technically, you can use another special set of units to define joules, which is kg/m per second, but usually we just go by joules because it's easier. So now we got the basics down, let's try a few example questions. Our first example question is, what is the kinetic energy of a 150 kilogram object that is moving with a speed of 15 meters per second? Our mass in this question is 150 kg. Our v is 15 meters per second, or velocity, and our kinetic energy is what we are looking for. Let's just quickly write that down so we get a clearer image of what we know. So m is equal to 150 kg once again, v is equal to 15 meters per second, and ek is the question mark. So let's write down our formula again to see what numbers we can plug into it. So our formula is Ek is equal to 1/2 mv squared, and we know that our m is equal to 150, v is equal to 15, so we do have sufficient amount of information to look for our kinetic energy value. Now we just have to do the math and we can type it all into our calculator. After doing that, we get an answer of 16,875. And our unit is going to be in joules. Alright, so we could leave our answer as is, but if we want to be more precise, we'll notice that 15 and 150, the values given in the question, both have 2 sig figs. So our answer should also have 2 sig figs. That would make our final answer 1.7 times 10 to the power of 4 joules. Box it up and let's attempt another question. Our second question is, an object has a kinetic energy of 88 joules and the force of gravity acting on it is 45 newtons. How fast is the object moving? We know that our Ek is 88 joules, the force of gravity acting on the object is 45 newtons, and what we're looking for is how fast the object is moving, so our v. So Fg is equal to 55 newtons, Ek is equal to 88 joules, and V this time is our question mark. Now let's write down our formula once again. So that's Ek is equal to 1/2 mv squared. However, this time, instead of plugging in our values right away, you'll have to notice that Fg, the 45 newtons, is not the mass. That is the weight, or the force of gravity. However, if we want to find the mass from the weight, we can use another formula, which is W, or Fg, is equal to mg on Earth. So 45 newtons is our W, or our weight, and 9.8 is our g, and mass is what we're looking for. Plug that into your calculators and you'll see that your mass is equal to 4.592 kilograms. Now we have the mass of the object, which means we have enough information to solve for our velocity. So 88 joules is your Ek, equals to 1/2 4.592 times v squared. Then we're going to multiply both sides by 2, so that will give us 176 is equal to 4.592 v squared. Divide both sides of the equation by the mass, and we get v squared is equal to 38.32. Finally, we're going to square root both sides to isolate v, and we get the final answer of v is equal to 6.19 meters per second. Now again, regarding the sig figs, we have two sig figs in each of the two values given in our question, so we can write the final answer as 6.2 meters per second if we want to be more precise. And that concludes my video on kinetic energy. I hope this helps, and thank you so much for watching, and I'll see you next time.